Buenas tardes. Obviously, I'm going to speak about artificial intelligence. And the question I will address is, can we trust artificial intelligence? Can we trust to use those systems that are called generative artificial intelligence systems, such as ChatGPT? To understand the stakes, let me start with the origin of artificial intelligence. This started in 1936 when Alan Turing, British mathematician, came up with the theoretical model of the computer, which is currently the model over which work all the computers in the world, including quantum computers, including what you have in your smartphones. Alan Turing was asking the question, what is computable in mathematics? Because in mathematics, you have some expressions that cannot be proven true or wrong, and he wanted to know what can be proven true, what can be proven wrong. And he came up with this idea, which forms the theoretical model of the computer, which is that what is computable, a computable function, is a function that can produce an output from an input using a finite number of steps. But you don't know how much. But it has to be finite and has to stop. Otherwise, it cannot be computable. So keep in mind that all computers work this way. They execute computations step by step, sometimes in parallel, and at some point they stop. They don't go forever and provide an answer. Why I am saying this? It's a mixture of science and technology, as Serge Haroche was mentioning the other day, because the same Alan Turing in 1950 has written a paper entitled Computing Machinery and Intelligence. And in this paper, he asked the questions, I propose to consider, can machines think? By machines, he means computers. And the question, of course, begs to define what is thinking and what is a machine. And he said, this would be very dangerous because we cannot define the meaning of thinking. And indeed, no one knows what does it mean exactly to think. In computer science, we don't, and in neuroscience, we don't, and in psychology, we don't. So he said, instead of doing this, I will just compare the machines to the humans, and this is called the Turing test, where someone is going to ask questions to a machine, a computer, and questions to humans, and if after sometimes they cannot distinguish which is which, it means we must admit that the machine thinks. Is this test now successful? The answer is no. No machine, no AI system has succeeded in fooling someone who asks the questions to find out who's who. We always determine that it is a computer. But based on Alan Turing work, in 1956, the new domain artificial intelligence was born. And I want to jump to today. Today, what is artificial intelligence? It's basically using techniques called machine learning. And in this slide, I tried to show the three main approaches to machine learning. Well, what is machine learning? Machine learning means we can provide data to computer programs which run on machines, on computer, and these data are going to be processed in different ways to extract information from this data. Instead of describing what we are looking for example, we want to identify faces, human faces and cats' faces, for example. We are not going to describe what a face is, but provide hundreds and thousands of examples, images of faces which are labeled human, cats. And what we are going to do is build a system. It's called a neural net on the upper hand left side. which is going to compute mathematically with a small number of computations, but put together, this is a large computation that is going to happen, which detect regularities, some pixel alignments on the images, and pixel alignments are not the same in human faces and in cat faces. So after the computation, you would have two clusters, two different possibilities. One is human for human faces, and one is cats for cats' faces. But how is this computation going to happen? It's based on this transmission between those neurons. Each neuron makes a small computation. It just computes a weighted sum of its inputs and provide an output to the next one. But if we have a good value, which is called W, synaptic weights, for transmitting this information, we will end up having the result which distinguishes the cats from the humans. And this process is an optimization process. It's a function called a backpropagation process, which was introduced some time ago by Geoffrey Hinton, for example, Nobel Prize of Physics this year, that enables to recursively compute those synaptic weights. And this is how the system learns. Actually, it's trained on the data to produce the different representations. And on the right-hand side, it's unsupervised learning. We don't know what you are looking for, but based on similar process, it's going to cluster the data in different categories, for example, here colors. And down there, you have a process called reinforcement learning, which is a sequential process during which the system is going to learn the best action to accomplish based on a very simple principle, which is if the elementary action is good, which means makes it progress to the goal, it receives a positive number called a reward. And if it doesn't lead it to approach the goal, it receives a negative number, for example, and it's a reward also, but it's a negative one. And then there is a function, which is very small and easy function that is optimized over time to select the best action. So these are the three main methods for machine learning. Now, we can do a lot with this. And let me move now to generative AI. So the first example I want to give you is called generative adversarial networks. In this case, you have two networks, similar to those I have just described, but they are going to be fighting each other. So we are going to provide a lot of images, for example, of a given painter, say Picasso style, and to the first network. And instead of using this network to discriminate, to classify, to predict new data, it's going to try to imitate the data distribution which is in the training set. And this is how it is trained. This generator, then if you input something which is just a white random noise, which means no information, it's able to produce an imitation, which is statistical imitation to the distribution of information which is in the data set. So we mean that this generator is able to forge, to fake a new image which resembles the initial set. And there is another net which will play the role of a discriminator, which distinguishes if this new image really belongs statistically to the initial data set. And if it says no, it doesn't belong, and it's trained, its synaptic weights are trained for that. If it doesn't belong, then you have to get back to the first generator, which will learn to better imitate, and so on until the discriminator doesn't distinguish what is true, what is false. And at the end, you have an image which is completely fake, doesn't exist in the distribution, it's not Picasso, and but it looks like Picasso. With this, we can do this. And make fake images of people in situations they never existed. You take images of the Pope, you take images of Balenciaga, you take images of French President Macron, you take images of a strike in Paris that was happening about garbage, and you fabricate a new image that makes you think that this is true, because we rely on images. And of course, this is misinformation if it's done for the purpose of misinforming people about reality. And this is where we see a first aspect in which AI systems can contribute to challenge our perception of reality. Let me speak about another kind of system, which are called large language models. Large language models, like ChatGPT, it's a large language model. The difference is that they don't just take images, they take text. And text is different from image, because in an image, you have all the information in the image. But in a text, in my speech, to understand what I'm saying right now, you must take the context of my speech since the beginning. So I hope you remember what I said since the beginning, because this is how you understand what I'm saying now, which means we need a context to interpret text. And there is a special architecture called transformer that can achieve this by taking into account context to produce the termination of a sentence. So here the difference is that we are not going to imitate, we are not going to predict. We are going to take an input, for example, a word, and after building this huge model, which is called generative model, this model, which is a model that has been built using a lot of data scrapped on the internet, data in Wikipedia, data in newspapers, data in poems, data in books. It's decomposed, the data is text, decomposed into characters, and the characters are used to statistically build a big model of a curation of a presence, co-presence of some words together. And this is the model here. And then when you say a new word, the new word will trigger an answer to your request, and this answer is what statistically comes after this word. If you say, I have eaten an apple, I have eaten N, what follows N? Could be anything, of course, but if I was saying, I went to the market, I bought a kilogram of apples, period, then I have eaten A, well, probably it's the apple that you have eaten, even if it's not. So statistically, you have the following, and then you continue this way. This is why they generate text iteratively that answer your request. But these systems, again, are statistical. So they also process data, text, and they process images. And if I use ChatGPT to ask it in last September, generate a realistic medical scan image showing lungs and liver, but not the heart, absolutely not the heart. The system produces this image, and you see the heart sitting in the middle. It says, here is the realistic medical scan image showing the lungs and liver with the heart deliberately excluded. What does this mean? It means the system A doesn't understand what it is saying, doesn't understand what is a heart, a liver, a lung. It has images, it has text, and these images and text that has been used to build this statistical model, there are hearts and livers and so on mixed together, but it's difficult for it to separate these various components. And it says, well, I'm answering your question, but I'm putting an image which statistically fits with what you say and what you ask. But actually, it presents a complete mismatch with reality. There is true and false information here. The true information is that the heart is here, but the system says it's not here. There are new versions of the systems. So I tried the same thing recently when I was preparing this talk about a week ago. And I asked the same question and got this image, which is different. But still, here is a realistic medical scan image focusing on the lungs and liver, excluding the heart entirely. And what we see is the heart. So the system didn't evolve, it didn't learn. Now, this is due to inherent limitations of those AI systems which are based on machine learning, statistical machine learning. So if you speak Spanish, you can look at the right-hand side. I hope I didn't make any mistakes, thanks to help from some friends. And here we have it's the opacity, the data bias, the design bias, the spurious correlations, the absence of causality, the unpredictability, the environmental costs. All these are limitations inherent to the systems. The absence of semantics, of understanding of what it is talking about. Because it is just processing sequences of characters, it doesn't have any grasp of the reality of the real world, about the meaning, the abstractions that we humans have. So in France, we have a National Ethics Committee on Digital Sciences and Technology, and we have come up with some issues, ethical issues identified by the limitations of those systems. These ethical issues raise the question of truth. What is correct? What is real? What is not real? The system mixes this up. It's not a misuse. It's by design that it's going to mix true and false information, as I showed you in this example. They are not able to reason. They will just statistically correlate things. And we tend to attribute human features to them because they speak, they use language, and language is the way we interact together, the way we understand things, the vehicle of reasoning. We build some dependency on that. So if we use them in education, what will happen to our critical thinking, our way to distinguish what is right, what is wrong? You go ask ChatGPT, you don't know if you get the result correctly. There is an issue about cultural diversity. 90% of the data that is used to build these systems comes from the United States and Western Europe. 90%, which means the rest of the world is not really culturally represented in the data. And it has environmental impact because of the large number of computations. So what this AI has as consequences on humanity. If we don't share common truth because we consult the systems and it tells you something to you and something else to me and something else to the third person, because it's in the silo and just your interactions, then how can we share the same truth? How can we know that we are agreeing on something which is common? And if we rely on AI systems, we consult AI systems always to have answers to our questions, how can we learn to think and reason? So often we say, people say, well, just give it the easy tasks and leave cognition to humans. But how did we build our cognition? We build it in doing easy tasks. We do it with experience. And therefore, we must do something about it. In Europe, there is a regulation on AI. This was built on the work of a group that was formed by the European Commission a few years ago to come up with recommendations for so-called trustworthy AI. And these recommendations here, 7 recommendations, basically say we must preserve human control. We must preserve human agency and oversight over the systems. we must ensure that the methodology to build those systems is robust and safe, which is not completely the case right now. We must ensure that data is well governed, that diversity and transparency are respected, and that the societal, which means the impact on democracy, is also respected, and that there is environmental well-being due to the fact that these systems are going to consume a lot of power and also emit carbon. And there is also the accountability of those who produce those systems. And the question, of course, which is asked in this great conference is, what do we want for our future? Well, we want that artificial intelligence remains a tool, a very powerful tool that we use for our flourishing, and not a means of coercion of humanity. Thank you very much. Muchas gracias.